Hey, in this video we're going to talk about slope, especially the slope of a line. All right, so what do you need to know before attempting this lesson? Make sure you're comfortable with simplifying fractions, working with negatives, and just knowing generally what is a line, straight line. All right, so if we were to kind of look at multiple lines at the same time, you'll see that one difference between these lines is how steep they are. All right, so just think about if these were mountains and you had a little like skier going down the mountain. Terrible drawing. All right, there's a little skiers going down. Who's having the most fun? This guy probably, because it's actually a line going down. This guy's falling backwards. This guy's falling really fast backwards. All right, but you can tell the steepness of the line is going to have a difference in how the skier rides down the line. And the steepness we just call the slope. Just like the slope of a mountain or the slope of a road or anything like that, we just use slope to talk about how angled this line is. All right, so what's the formula? How do we talk about the slope? How do we differentiate one slope from another? There's a bunch of different ways. All right, so the first thing is a lot of times m gets used for slope. All right, so m is just a letter that gets used for slope a lot. There's kind of three different ways to think about it. If you have some points on your line, I have 2 points that are x, y. If you subtract the y values and you divide by subtracting the x values, that'll give you the slope of the line. The other way is rise over run. So rise is how much you have to go up to get between these 2 points, and run is how much you have to go left to right to get between those 2 points. All right, so rise divided by run. And the last way, change in y over change in x. So I think this one's most useful when you're given points. This one's most useful when you're given a graph. This one's most useful if you're given some type of real world situation. All right, change in y over change in x. All right, how much is the y value changing divided by how much is the x value changing? All right, so let's calculate the slope of each of these lines that we looked at earlier. And the way that's going to help, I think, whenever you're given a graph, the formula for slope you want to use is rise over run. So if we start with the blue graph, I want to find two nice points on my graph. Really, you can use any points, but it's a little bit harder to guesstimate what's happening. So I always look for points that are kind of on these tick marks. So right here is a nice point because it's right on the intersection of some values, and another one is right there. So how much do I rise between these 2 points? All right, my rise to get from this point to here, how much do I go up? I had to go up 1. So my rise is 1. How much do I have to run? I have to run 1, 2, 3, 4. So the slope of my blue line is a rise of 1 over a run of 4. All right, now let's look at the red line. All right, let's find some nice points on the red line. There's one right there and another one right there. Again, I'm just looking for those points. I kind of go through those exact values. My rise in this case, I had to go up 1, 2, 3. All right, so my rise is 3 and my run is 1. So the slope of my red line is a rise of 3 over a run of 1. And I can just simplify that fraction into just 3. So that one has a slope of 3. All right, and lastly, I have green. Let's find some nice dots. There's a nice intersection there and a nice intersection there. All right, I'm always kind of working left to right, just like we read graphs work the same way. I'm working left to right. So if I have to rise, I'm going from this point down 2 to that point, and then right 3. So the slope of this green line down 2, my rise is actually negative. I'm going down is -2, and my run is 3. All right, so just know that if your line is ever going down in this direction, your slope is negative. All right, if my line is going up, my slope is positive. Because I'm rising up to go positive, I'm rising down to go negative. All right, so that's how you use rise over run and the graph of a line to find slope. What about if I'm just given information? All right, calculate the slope of the line that goes through these 2 points. All right, you may remember from another slide that our formula looked like this. All right, y2 minus y1 over x2 minus x1. Some people get a little scared by the little subscripts. That just means the second y value minus the first y value. So my second y value, I go to my second point, and the y value is -3. Then I go to my first point, and my y value is +3. And you notice I'm putting parentheses around the numbers because it kind of helps you with the negatives because there's that subtraction sign. On the bottom, I have x2, so I go to my second x value, that's 1. I'm going to subtract my first x value, that's -2. All right, so on the top, I can simplify -3 minus 3 is -6. On the bottom, I said, remember when I subtract a negative, these two cancel out and just make it addition. So 1 plus 2 is 3. And then I simplify my fraction, -6 divided by 3 is -2. So if I were to have this line, just a real crude drawing real quick, at -2, 3, and 1, -3. All right, this line has a slope of -2. And it makes sense that our answer is negative because you can see this line would be going in the downward direction. All right, and here's one for you to try on your own. All right, just work on finding slope given points. All right, so what is the slope of this line? All right, I'll show you the answer in 3, 2, 1. The answer I got is 3. All right, but I actually did something a little weird just to show a point, is that the way that I assume most of you solved it was down here in this red box. All right, my second y value minus my first y value for second x minus my first x. All right, that's perfectly fine. That's how you're supposed to solve it, really. But I just want to show on the top here that doesn't really matter which one you call your first point and your second point. So I solved it as if this was my second point and this was my first point. Because there's really no reason when I typed this, I could have typed them in the opposite order, and you can see you get the same answer. So it doesn't matter which one you call the first or the second point. What matters most is that you get the associations right. 5 and 2 are related, so they should be above each other in the fraction. -4 and -1 are related, so they should be above each other in the fraction. But it doesn't matter which one you call first and second. All right, so go ahead and practice finding slope of lines. All right, really it just helps you understand a bit more about lines and working with these formulas.